People know that this is a different kind of place, you know, that we live in the landscape, in the environment. It's the natural wilds and wonders of the southwest, but actually driving the economy through that.
The southwest is a natural powerhouse. It's got these amazing georesources underneath the ground. It's got the opportunity for floating offshore wind. And I think a powerhouse is when you take the most of all of these separate opportunities and work with them together for the same purpose.
I think a really important facet here is that we are able, in the southwest, to leverage world-class research and use it and apply it to the business world.
Looking 20, 30 years down the line, things like offshore wind, things like geothermal energy, things like more intelligent use of our natural resources, then trying to create a sense of real community to go forward.
Well, it's hot down there. Geothermal energy is heat from the earth, and it's the ability to use hot water from the ground to produce electricity. It's clean, green energy, and we need that to move forward.
We have a real opportunity here in the southwest to take the lead in deployment of new technologies for offshore and marine renewable energy. Wave energy, tidal stream and floating offshore wind, and the power in the waves is evident every day.
You know, the aspects about the natural powerhouse is trying to be smart about this, and by smart I mean looking ahead. What is coming down the line? And being able to manoeuvre yourself in a position that you're ready for it.
We have minerals and resources here that aren't anywhere else in the UK, and we have geothermal energy here. The rocks are hotter here than anywhere else in the UK.
It's about understanding that we are an integral part of the environment that we live within, that humanity isn't separate from nature in some way, it's part of it. If we're going to transform the economy to one that's truly sustainable, we have to engage with all of those natural resources.
So it seems to me that the natural powerhouse is an essential contributor to the success and long-term well-being of the southwest.
Hello, my name is Dr. Kate Smith. I'm a research fellow at the Camborne School of Mines, University of Exeter, and my research is focused on the environmental and social impact of mineral exploration as part of a larger project that's a Horizon 2020 European funded project called GreenPeg. GreenPeg's aims to develop and test exploration techniques that will be integrated in ready-to-use tool sets for the identification of buried pegmatite bodies. So pegmatites are igneous rocks, and they are formed underground. They typically have crystals that are larger than 2.5 centimetres in size and often much larger. And they're important for our green future because they contain critical raw materials that are needed for energy technologies and for digitization. So for example, lithium, which is used in electric car and vehicle batteries, and high purity quartz, which is used as a casing on fibre optic cables, which are needed for high-speed internet, and also for in semiconductors that are used in computers, for example, as well as other applications. Pegmatites are common in Europe actually, but they're quite difficult to explore for because they're buried and they're small and they're clustered. They're not at the surface and they're not great big large bodies of rock that are easy to find. So in GreenPeg, the techniques that will be used to try and find pegmatites include geological and geophysical techniques such as drone and helicopter surveys, geochemical analyses, and satellite data processing. And these will be put together as packages of exploration techniques. The goal is that they will be effective and reliable for finding pegmatites, ideally at low cost, and they will importantly have be environmentally and socially low impact. The research that I'm involved in Cornwall, along with my colleagues at Camborne School of Mines, Professor Francis Wall, Professor Ben Williamson, Dr. Zhao Yuyan and Dr. Robert Pell, is focusing on assessing and minimising the environmental and social impact of these exploration techniques. And in particular, we're applying an approach called life cycle assessment to this challenge. So life cycle assessment is very commonly used in manufacturing and product development to assess, minimise and to demonstrate to investors and customers what the impacts of a product or a process are. That includes over the whole life cycle from raw materials extraction to product development and manufacture, transport to point of sale, use of that product, and then eventual end-of-life treatment. By looking at the whole life cycle of a product or a process, impacts that seem quite distant, such as that don't feel something you might think about when you're using that product, can be considered, such as the fuels that are used in the production as well as the use of the product, the materials that go into it and the production of those materials, equipment and vehicles that are used in all stages of the life cycle. It can also include the impacts that might seem very geographically distant. So for example, if you're driving a car in the streets of London, that car in its whole life cycle might have impacts in Africa through mineral extraction, or perhaps impacts in China to do with production of a battery. The sort of impacts that are focused on in life cycle assessment often include those to do with carbon dioxide and methane emissions, the global warming potential. But other sorts of impacts can also be considered. So all different types of pollution to water, soil and the air, or toxicity to impact on human health and also health of animals and vegetation. And increasingly, social impacts are being included in life cycle assessments, particularly to do with human rights. By understanding all these impacts to the whole life cycle of a product or a process, such as exploration process, this allows us to make informed choices about maybe changing a product development process or perhaps whether we want to buy a certain product or not. Life cycle assessment is now more commonly being used in mineral extraction and processing, so mining related applications. And since responsible mining and responsible sourcing of raw materials starts upstream with exploration, then in GreenPeg we're applying these life cycle assessment techniques to the exploration techniques that are being developed within the project. This is going to allow us to transparently share information about environmental and social impacts that these exploration techniques have with our project partners as they're working on them, and also with final end users, exploration companies. And then they can share that information with their customers and their investors. We will be able to include this information about impacts in the information that goes with the tool sets, with the collection of different exploration techniques that will be recommended for pegmatite exploration. And this will allow fully informed, responsible decisions to be made about their use. So overall, our research will contribute to the solutions for green futures by lowering the impact of mineral exploration. And our research outputs, which will initially be applied in Europe, will be applied worldwide. And that will overall improve exploration for critical raw materials that are needed for the energy transition.
My name is Will Nash and I'm a postdoctoral researcher here at the Camborne School of Mines, University of Exeter. The main purpose of the research that we're conducting here is to lessen the demand for new mines. The further we can reduce the need to build new mines, the better. To this end, we're looking at ways of extracting valuable metals from mine waste instead of building new mines. The waste we're looking at the moment is coal combustion products. which are the grey powder material that comes out of coal-fired power stations and which contains all sorts of interesting metals, in particular rare earth elements, which are having a little bit of time in the limelight at the moment because of their applications in optical and electronic devices. So we're looking for ways of extracting these rare earth elements from coal-fired power station waste. There's an enormous amount of this waste. In 2016, more than 1 billion tonnes was produced globally. So there's an enormous scope to recover large quantities of valuable metals from these, and thereby, at the same time, if we're clever about the way we extract these metals, actually remove the hazard posed by this waste to the environment. Although we're conducting this research here in Cornwall, the kind of waste that we're looking at occurs worldwide. Enormous quantities of coal combustion products are generated every year in the USA, in India, in China, and here in Europe. So the techniques that we're trying to develop to extract useful metals from these can potentially be applied anywhere in the world.
My name is Reski Shahrir. I am a PhD student in the Camborne School of Mines, University of Exeter, and I'm studying social economic and sustainability of mining, focusing on the resource governance in mining rich regions. My study aimed to analyze the social economic contribution of mining to sustainable development. I took a case study from Singkep Island in Indonesia. It was tin mining regions that used to be rich with mineral resources, and the mining regions as a complete mine life cycle from exploration to mining development and active mining, production, and until the mining closure. And the mining was closed around 30 years ago. Interesting to see this case is because we can learn from their experience that even though mining region was prosper in the past, it doesn't necessarily for them to sustain the mineral benefits after the mining closure. The importance of this research is to identify the social economic symptoms that the mining regions had in the past that might determine their future, whether they will sustain the mineral benefits or they might not sustain the mineral benefits after the mining closure. What we can learn from this experience that what this research can contribute to Cornwall and to the future of mining industry worldwide, that this case study was like similar what was happened in Cornwall 30 or 40 years ago when Cornwall was rich of tin mining. But quite surprisingly that there was not so many research on what was happened actually in Cornwall, what was the characteristic in Cornwall in the past, and after the mining closure, many unemployment arise. And what can be learned from the experience that in Indonesia, that Cornwall might have a similar experience. And the important thing is that the sustainable development that I want to propose to Indonesian government may also apply here in Cornwall. For instance, in my research, I identified that mining regions that well known as prosper region in the past, they have better education, they have better income, they have better infrastructures, but after the mining closure, most of the benefits and immediately, and the mining regions fell into a social economic recession that they could not imagine before. So I try to propose the intervention to the socio-economic characteristic that they had. I identify that one of the characteristics the mining regions may have that may lead to unsustainable development is mining dependency. Even though they experience a higher income, but if the mining regions is characterized a high dependency, it is actually vulnerable for them, and they are likely to not to sustain the benefit, the mining benefits after the mining closure. The task or the assignment for the government or the local community is to make the intervention that when they can get benefit from mining, they have to make sure that the mining regions in the local community develop in the way that they are moved from this dependency. This is the way how to make sure that when the mining closes, the mining benefits can sustain and to the local communities, and the local communities may enjoy the benefit from mining as well, and after the mining closure, the benefit will continue in the future. Another thing that government can learn, also the Cornwall government can learn, is that they have to make sure that when mining in Cornwall, because tin mining in Cornwall, I heard that they want to redevelop it, and there will be also investment in tungsten, like for instance, or like lithium to support the greener future. These activities, these mining activities to support the greener energy in the futures is important, is essential, but that is not actually the main reason for this kind of exploitation, or the main reason of the activities. While we are mining tin, for example, or when we produce lithium to support the greener energy in the future, we have to also make sure that this lithium production will benefit the local communities here in Cornwall and make the local businesses grow together with mining companies and move away from mining dependency. And therefore, when anytime the mining is closed, these other businesses can still grow, and the local communities can still enjoy the benefits, and they can get economic growth for non-mining activities. That's the one of the important of the resource governance in mining regions. Thank you.
My name's Eva Marquis, and I am a postdoctoral research fellow at Camborne School of Mines at the University of Exeter. I'm part of the Circular Economy Centre for Technology Metals. This Circular Economy Centre is trying to get together a range of interdisciplinary researchers to come up with a roadmap for the circular economy approach to technology metals across the UK. My research in particular is looking at the geological aspects of this. So I'll be looking at circular economy geomodels for these technology metals. Technology metals are those that are used in really small amounts, but in a real range of digital and green energy technologies. As such, they're not usually the focus of mining exploration companies. Most of the time they go after the so-called big metals, copper, aluminium, iron. Instead, we want to look at things like lithium, bismuth, indium. All of those things are used in those small quantities, but are really crucial for the enablisation of those green digital technologies. What I'm planning to do is to develop these geomodels. So geomodels are 3D representations of the geology below the subsurface, and they're principally used by exploration companies to firstly understand the deposit style that they're looking at, to figure out where they might have concentrations of metals, but they're also used in the mine planning phase to be able to identify which is the next bit of ground that they should target, which bit of rock they should dig up. These geomodels, however, don't usually include things such as mine wastes, and quite often they use fairly typical industry standard techniques for metal extraction. What we're planning to do is to expand these scenarios to include mine wastes, where we might have accumulations of technology metals that might not have previously been tapped into. Additionally, we want to look at the surrounding industrial ecosystem to start bringing in other processing plants. So not only look at from the mine to the processing plant and developing the metal, but go further and actually look at the full ecosystem through to the development of a product and then the recycling of that product, and seeing if we can then reintegrate that back into the metal production back at its start point. This will allow us to kind of develop these full circular economy scenarios, and the aim of these circular economy scenarios is to basically have an economy that is beneficial for the environment, for society and economies all together in one go. To do this, we're going to be using a case study across Cornwall. Cornwall has a really rich mining heritage, so it's a great place to start when looking at circular economy geomodels. What we want to do is bring in novel processing technologies. We want to bring in new techniques such as life cycle assessment and integrate these into our geomodels that will include those mine wastes, be that from historic mining or new mining popping up in the area. And we want to develop tools that will be able to be applied around the world so that we can really embed those environmental, social and economic values into the early stages of exploration. And what we want to do is take what we've learnt from developing this geomodel in Cornwall and apply this tool elsewhere so that we can embed those environmental, social and economic metrics into geomodels from a very early stage of the exploration process, so that when we are looking for technology metals around the world, we know that we can mine them in the most sustainable manner possible.
Hello, my name is Frances Wall. I'm a professor at Camborne School of Mines at the University of Exeter.
I carry out research on some of the Earth's most rare and special rocks that contain metals that are now facilitating technological advances in areas such as consumer electronics and the decarbonisation of transport. In this course, we're going to look at these previously little known and even rather obscure elements that have become so essential. We will call them technology metals, and we use them every day without thinking about where they really come from. But they're the enablers of our digital technologies, renewable energy generation and low carbon transportation. Over the next 4 weeks, we're going to be investigating how these technology metals form in the earth and become concentrated into mineable deposits, where in the world deposits of these metals are located, how we as geologists find the deposits, and then how engineers and chemists extract the minerals and their metals from the host rocks. And of course, where these elements end up being used. We'll consider the environmental impact of obtaining these essential raw materials and explore the possibilities of recycling and a circular value chain. The aim of this course is to show the growing importance of these raw materials in our modern world and outline their pivotal role in our global communication networks and in our technologies that help facilitate decarbonisation. We look forward to taking you on this journey through the life cycle of technology metals that permeate our modern world.